Right now, as you watch this video, astronomers are monitoring over 40,000 potentially habitable exoplanets. And here's the kicker. In 2026, we've detected potential biosignatures on 12 of them. 12 worlds that might harbor life. The question, are we alone in the universe, isn't just philosophical anymore. It's becoming scientific fact that we're on the verge of answering. And the implications? They'll change everything we know about our place in the cosmos. Let's start with the numbers, because they're absolutely staggering. Our galaxy alone contains an estimated 400 billion stars. The observable universe? 2 trillion galaxies. If even a tiny fraction of those stars have planets, and a tiny fraction of those planets have the right conditions, we're talking about billions upon billions of potential homes for life. The math alone suggests we can't be alone. But here's where it gets wild. In 2026, the James Webb Space Telescope has revolutionized our search. It's not just finding exoplanets anymore, it's analyzing their atmospheres, looking for the chemical fingerprints of life. What are we looking for? Biosignatures. Things like oxygen, methane, and water vapor in specific combinations that on Earth only exist because of living organisms. And we're finding them. K2-18b, a planet 120 light-years away, has shown strong evidence of dimethyl sulfide in its atmosphere. On Earth, this gas is only produced by ocean phytoplankton, only by life. Now, scientists are being cautious. Could there be non-biological ways to produce these chemicals? Maybe, but the more planets we study, the more these signatures appear, and they're getting harder to explain away. Let's talk about the Drake equation. Back in 1961, astronomer Frank Drake created a formula to estimate the number of detectable civilizations in our galaxy. In 2026, we can actually plug in real numbers. We now know the rate of star formation, the fraction of stars with planets, and even how many planets per star are in the habitable zone. The updated equation suggests there could be thousands of intelligent civilizations in the Milky Way alone. So if they're out there, where is everybody? This is the Fermi paradox, named after physicist Enrico Fermi. With billions of years for civilizations to develop and spread, why haven't we seen definitive proof? Maybe we're looking in the wrong way. SETI, the search for extraterrestrial intelligence, has expanded beyond radio signals. In 2026, we're hunting for technosignatures, artificial lights on exoplanets, megastructures around stars, even atmospheric pollution. Think about that. We're literally looking for alien smog, industrial pollutants that could only come from advanced manufacturing. If we can detect them, it means we've found not just life, but technology. There's also the concept of Dyson spheres, massive structures that could surround a star to harvest its energy. While we haven't found one yet, astronomers are actively searching for stars with unusual dimming patterns that could indicate such megastructures. But let's get real for a second. Maybe the reason we haven't found intelligent life is because intelligence is rare. Earth existed for 4 billion years before humans showed up. That's a long wait. Or maybe it's the Great Filter Theory. Somewhere between simple life and galaxy-spanning civilizations, there's a barrier that almost no one passes. The terrifying question is, are we past it, or is it still ahead of us? Here's another possibility that'll blow your mind. Maybe they're already here, and we just don't recognize them. What if alien life is so different from us that we literally can't perceive it with our current technology? Think about it. We're carbon-based life forms looking for carbon-based biosignatures. But what about silicon-based life? Or something even weirder, like organisms existing in the clouds of gas giants or in the quantum foam of space-time itself? In our own solar system, the search continues. Europa, Jupiter's moon, has a liquid ocean beneath its icy surface. Enceladus, Saturn's moon, shoots geysers of water into space. Both could harbor microbial life right now. In fact, NASA's Europa Clipper mission, which launched in late 2024, is currently on its way to investigate. By 2030, we'll have unprecedented data about Europa's ocean. We might find our first aliens without even leaving our cosmic neighborhood. Mars is another candidate. While its surface is a frozen desert now, evidence suggests it once had rivers, lakes, and maybe even oceans. If life emerged there, it might still exist underground where liquid water could remain. The Perseverance rover is literally collecting samples right now that will be returned to Earth in the early 2030s. Those rocks could contain fossilized microbes. We could have proof of alien life, even extinct life, within this decade. Now, let's address the elephant in the room: UFOs, or as the government now calls them, UAPs, unidentified aerial phenomena. In 2026, the conversation has shifted from conspiracy theory to legitimate scientific inquiry. The Pentagon has released multiple reports confirming that military personnel have encountered objects performing maneuvers that defy our understanding of physics. Does this mean aliens? Not necessarily, but it means something unexplained is happening. Most scientists believe these phenomena have terrestrial explanations: advanced technology from other nations, atmospheric effects, or sensor errors. But they're studying them seriously now, and that's a huge shift. Here's a perspective shift. Maybe we're asking the wrong question. Instead of, are we alone? Maybe we should ask, when we stop being alone? Because at the rate we're advancing, we might create artificial intelligence that counts as alien intelligence. Some scientists argue that artificial superintelligence would be so different from biological intelligence that it might as well be alien. And we could create it before we find extraterrestrial life. Wild, right? Let's talk about communication. If we do detect an alien civilization, talking to them will be nearly impossible. The closest potentially habitable exoplanet is 4 light years away. That's an 8-year round trip for any message. Most exoplanets we're studying are hundreds or thousands of light years away. Any civilization there could have risen and fallen multiple times before we even detect them. We might be finding ghosts, not neighbors. There's also the question of whether we should even try to contact them. Stephen Hawking famously warned against it, suggesting that advertising our presence might be like Native Americans meeting Columbus. Not everyone agrees, but it's worth considering. Despite the warnings, we've already sent messages. The Arecibo message in 1974, the Voyager Golden Records, even commercial broadcasts leaking into space. For better or worse, we've been announcing ourselves for decades. In 2026, breakthrough initiatives are planning to send more powerful, targeted messages to promising star systems. Within our lifetime, we might get a response. Imagine that moment when we receive an intentional signal back. The truth is, in the last decade alone, our understanding of this question has transformed completely. We've gone from wondering if planets exist around other stars to analyzing the atmospheres of potentially inhabited worlds. We've discovered that the ingredients for life, water, organic molecules, energy sources, are everywhere we look. On asteroids, on moons, in the clouds of Venus, in interstellar space itself. The universe is teeming with potential. Recent studies suggest that amino acids, the building blocks of proteins, can form naturally in space and survive delivery to planets via comets and asteroids. Life's recipe might be getting delivered constantly throughout the universe. Here's something most people don't realize. We've only seriously searched for alien signals for about 60 years. That's nothing. The universe is nearly 14 billion years old. We've barely started looking. It's like going to the ocean, dipping a cup in the water, seeing no fish, and concluding the ocean is empty. Our search has been that limited, but it's expanding exponentially with new technology and new methods. If this exploration of the universe's biggest mystery is blowing your mind, do me a favor. Hit that like button and subscribe to Your Space Wizard. We're making the cosmos accessible, one mind-bending video at a time. Looking ahead, the next generation of telescopes will be game changers. The Extremely Large Telescope, completing construction in 2028, will have a mere 39 meters across. It will directly image Earth-sized exoplanets. We'll be able to see continents, oceans, maybe even cities if they're there. Within a generation, we might not just detect biosignatures. We might actually photograph alien forests or artificial lights on another world. There's also the breakthrough Starshot initiative, planning to send tiny spacecraft to Proxima Centauri at 20% light speed. They could reach our nearest neighboring star system in about 20 years and send back actual photos. Imagine that. Actual close-up images of an exoplanet. Not artist renderings, not data interpretations, but real photographs of another world orbiting another sun. It could happen in our lifetime. So back to our original question. Are we alone in the universe? Based on everything we know in 2026, the honest answer is probably not. The universe is too big, too old, and too full of the right ingredients. The better question might be, how long until we find them? And that answer could be soon, maybe within the next decade. Maybe we already have the data and just haven't recognized it yet. Some scientists estimate we have a 50% chance of detecting definitive proof of alien life within the next 25 years. Others think it could happen any day. The James Webb Telescope takes new data every single night. When it happens, and not if, but when, it will fundamentally change humanity. Every religion, every philosophy, every assumption about our uniqueness will have to be reconsidered. It'll be the most important discovery in human history. Maybe the real answer is that we're alone right now, in this moment, but we won't be for long. We're either about to find life elsewhere, or we're about to spread life throughout the cosmos ourselves. Either way, the loneliness ends. Thanks for joining me on this journey through the cosmos. What do you think? Are we alone, or are we just not looking hard enough? Drop your thoughts in the comments. And remember, keep looking up, space wizards. The universe is waiting.